Hello everyone, today we'll look at 19.3 HR diagrams. So HR diagrams, Hertzsprung-Russell, and what they do is they show where different stars lie based on their life cycle. So last lesson we looked at the life cycle of different stars and the different routes that they may take. Whereas what we're looking at today are how they compare with their luminosity, and we'll talk about what that means, and also their temperature. And what we see is they sit quite nicely when you look at those two areas. So, as the slide says, stars do vary, and they are different by their mass, by how bright they are, by their diameter, their luminosity, surface temperature, and also their colour. So HR diagrams of stars from our galaxy with luminosity against their average surface temperature, and that's what's plotted just here. So we can see that white dwarfs, bottom left, and the red supergiants over there. Our sun is just about there, and there are different names of stars, some of which we'll look at in the course, other ones that you'll see appear by looking around at different HR diagrams, but we won't be talking about as such. A couple of things to note that people do miss is that luminosity increases, but the temperature goes down, and that's a key part of a HR diagram. In some exam questions, and there'll be more of those as the course goes on and we learn more in general, because quite a lot of the questions are mixed with other bits of knowledge as well that we haven't yet covered. Just always look at this one, because sometimes in exam questions the temperature goes down and sometimes the temperature goes up, so that's something for you to watch out for at a later point. Now, I've used the word luminosity. It is absolutely related to brightness, but that is not what it is. Luminosity, we talk about it in terms of power. So therefore, the unit of luminosity is the watt. Okay, it's the total radiant power. And what you'll see is at part A, that's the hottest, most luminous stars, so that's top left. The coolest, least luminous stars are down here, and what you'll see is the colour changes. So blue stars we say is very hot. Our sun's somewhere in the middle, so that's yellowy orange, and as a star gets cooler, its colour goes redder. So most stars do sit in this region between A and B, the main sequence, and our sun is somewhere in the middle, as I mentioned. So the very hot but dim stars we would call are our white dwarfs at point C, and the red supergiants, which are really luminous, in other words, they're very, very powerful, but they do have a relatively low temperature, so that's why they're red. And then smaller red giants are at E. It's certainly worthwhile just referring to this area just there with the HR diagrams, the bits that you need to focus on. So we've mentioned luminosity and temperature plotting. You need to be able to identify the main sequence, where the red giants are, where the red supergiants are, or super red giants, and you need to be able to draw where the white dwarfs are. So it is definitely worthwhile practicing and drawing this out a number of times and labelling where the different stars are found. And in addition to that, there are often questions where you have to draw on where the sun is. So if you imagine this split into quadrants, generally speaking, you would draw the sun on the edge. So slightly different to the diagram that I've got on here for you. So linked to that is something called stellar evolution. And again, you need to be able to use these diagrams to talk about the order in which things happen. So this is another diagram. So you can see the sun. And what will happen to our sun is, as you're aware, it will turn into a red giant over time. So it will get slightly cooler and slightly more luminous. And then over a bit more time, it will then come around here and turn into a white dwarf. So the temperature will get hotter, but over time it will get less luminous, it will get dimmer, and eventually it will fizzle out like so. So you do need to be able to identify that loop of the life cycle of our sun in relation to a HR diagram. And likewise, higher mass stars are about there, and what they do is they just move to Y, and then after that they'll turn into a supernova. 19.3 is quite a short chapter, but one that you can certainly spend quite a long time looking at, and then remembering how to draw the diagrams and then where everything lies within that diagram. So obviously read the chapter in the book. I've also provided you with an excerpt that I'll put on to show my homework, going through the same but just from a different textbook. But if you can have a go at the summary questions as well, and then of course mark them, and any queries or questions, get back to me and I will try and do a little video of them or meet you live as and when. You should have got access to Caboodle, but if not, here are the questions for you to have a go at. And as I said earlier, as we go through this chapter, there'll be more past paper questions that I can give to you, and then you can send back for me to mark. But until we've done a few more sub-chapters, it's quite difficult to find questions that are quite separate from all the other knowledge that you do need to have in the first place. Hope you're all well, and be in contact, and see you again on Friday.